When we talked about isosceles, we do have different vocab. You may have learned back, I think it starts in 4th grade, and then we probably reviewed a little bit in pre-algebra. The two congruent sides, what are those called? We talked about this a couple days ago, maybe last week. What are the congruent sides called? Right, they were called the legs. The angle where the legs intersect, so up at angle B, that's going to be called the vertex angle. And the side opposite the vertex angle is going to be called the base. So we're talking about side AC. So it's opposite the vertex angle. And it's called the base. Okay. So we have the legs, we have the vertex angle, then we have the base down here. Where the base is, that's where your base angles are going to be. So the angles along the base are called the base angles. The way the angles and the sides relate is if you have two congruent angles, so that would be angles 2 and 3. These base angles, the reason they're equal is because they're across from the congruent sides. So there's this relationship between the angle measures and the sides that if the angle opposites are equal, the angles will be congruent. Or if the legs are congruent, the angles will be. I think I said the same way twice. The angles are equal across from it, the legs are equal across from it, the angles are equal. Not that these two theorems are. So we have the isosceles triangle theorem. It says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So the way it would look in a proof, it would say if segment AB is congruent to segment BC. So if the legs are congruent, then the base angle, so we would say angle A is congruent to angle C. So if the legs are congruent, then the angles are congruent.
Or 2 and 3.
Yes.
The same thing.
Yep.
Okay.
Get it. Then the opposite is true. Remember what the converse does is you're flipping the if and the then. So we're taking what we had in the then, so we're going to talk about the angles first, and then we'll talk about the sides. So the converse flips it. So the converse is saying if the two angles of a triangle are congruent, we're going to say if angle A is congruent to angle C, I should say if, then the sides opposite those angles are congruent. So we say segment AB is congruent to segment BC. We're going to start out just looking at numbers and then looking at the algebra. We won't get into proofs for, I think, another section or two. So for number 1, how we're going to apply this is they're marking the legs are congruent. So that means the angles opposite those legs have to be congruent. So what would the measure of angle J have to be?
68.
68 is well, so it's opposite. Very good. How would I go about finding the measure of angle K, which is our vertex angle?
68 plus 68 is 80.
Yeah, so 180 and then subtract the 2 knowns. And what do we get? How many of you calculators, guys? Guys? Guy. One guy. 44, exactly. Okay, so that's an example where they give you one of the base angles, and that's how we're going to find the other two. If you look at number 2, what angle are they giving us? What do we call that angle?
Vertex angle.
It's the vertex angle, right? So if we know the vertex angle is 106 degrees, how are we going to figure out the base angle?
80 minus 160 divided by 2.
Yeah, and I think you meant 106.
Oh yeah, 100.
So 180 minus 106, what would I get there?
47.
What would I get
74.
74, there we go. Alright, and then we're going to take that number like Noah said and divide it by 2. So what's 74 divided by 2?
37.
Okay, both of the angles need to be equal because we're splitting them equal, so they're both 37 degrees.
Because just the mean, right?
Add up 106 plus 37 plus 37. And it should equal? Good question, Katie. All right, number 3, now they're giving you the base angles. What are the base angles telling you?
Not congruent.
Say it louder. That they're the base because they're equal, very good. And then what is it telling you about the sides? Yeah, so if I have x, y is 12 centimeters, what other side would have to be 12 centimeters?
YZ.
YZ, because it's opposite angle x. This is also 12 centimeters. Can we figure out XZ?
No.
No, until we get to trig, you cannot figure out XZ.
77?
I mean the side XZ. Alright, so I can figure out angle Y now. How do I figure out angle Y?
180 minus 77 minus 63.
Very good. What do we get?
27.
26 is very good.
Do we need the centimeters?
No.
Yes, we do.
Not for the inside.
What?
She's talking about for YZ.
Sorry, for YZ, yes. We need centimeters. We need degrees for the other one. But it matters. Like, we need to know what unit you're measuring in. What makes a difference? You guys tend to forget. So I keep calling it out.
Please do. Alright, number 4, now we're getting into the algebra. How do we know how to solve for x? What does the figure have in it that lets us know? Brooklyn, can you say it louder? Yeah, these are indicating that they're congruent. Well, we now know that the opposite sides have to be congruent, or the opposite angles, I should say. So if these two angles are congruent, what's my equation going to be? Perfect. 5x plus 9 equals 8x minus 30. So we're going to subtract 5x from either side, and I'm going to get 3x on the right side. Add 30 to get 39. And then what does x equal? Perfect. And number 5 is just like it, so let's keep moving. What in number 6 is indicating how we can set up this equation? What markings are in there? Yeah, these little arcs are indicating that these two angles are equal. What does that tell us about the opposite sides? They're equal as well. So now what's my equation? Perfect. So we're going to subtract 15x from either side, which would give us 8 on the right side, add 17. 7 plus 17 would be? There you go. And now what does x equal? And number 7 is just like it, except they put numbers in. Does anybody need to see 5 or 7? 7? Okay. So we have 74 and 74. If these angles are the same measure, that means they're congruent. So what does that tell us about the opposite side?
Congruent.
How is my equation?
74 equals 3x plus.
I think you're overthinking it.
It's just letting you know they're congruent. That's all we need the 74s for. It's just like if they mark them congruent.
9x minus 73 equals 3x plus 4.
Very good. So don't do anything with the 74. I'm glad we're going over this one. I didn't think about that. Once you know those angles are congruent, don't try to put it in with the sides. We can't do anything like that until trig, and even then you have to go way beyond because these aren't right triangles. So just set the sides equal. Now we're going to subtract 3x from either side, so the left side is 6x plus 23 plus 73. Plus 73. 96. There we go. And what would x equal? Perfect. Alright, let's go on to the next page. Now we're going to have to draw the images, I believe. Alright, number 8 says, in triangle RST, if segment RT is congruent to segment ST, the measure of angle R is 9x plus 2, the measure of angle S is 13x minus 18, and the measure of angle T is 17x plus 1. So you need to find x and the measure of each angle. There's a workaround here, but since we are dealing with isosceles, we're going to go ahead and do it this way. Alright, so which is my vertex angle? And that's what I was just saying, yes, there are more than one way to do it, but since we're learning this way, you're not always going to be able to do it that way, so much to understand it. It depends on what the information is given.
So suggestion, draw it.
Draw it.
Because you'll make fewer mistakes. That's what she's trying to tell you. Yes, you can do it right through the problem, but she wants you to learn to not make mistakes.
And you need to know how to use it with isosceles, because the word problems will change and get harder. Alright, so what's my vertex angle?
R.
Not
R. This one's a little tricky. S or T? I'm hearing
S.
multiple things. Why do you say S?
Because it's the middle.
So, we know about the name of the triangle.
So these are my congruent sides.
It would be T because of both R and S.
So if T's at the top, then I could make this work.
You can name it any way you want. You don't have to name it in that order.
Oh yeah.
When they named it RST, it doesn't necessarily mean it's in the order.
Alright, so if I were using the base angle theorem that we just learned, actually I think it's called the converse of the isosceles triangle theorem in this unit. What would I do with these expressions? Which two would I use?
S and
Yeah, because those are opposite the congruent sides. So then I'm grabbing these two, saying 13x minus 18 is equal to 9x plus 2. Now we're going to subtract 9x from either side to get 4x. We're going to add 18 to the 2. So 4x would be equal to? Good. And what is x equal?
Do you guys see how right now T is extra information? Do you guys see that? Because it looks confusing, but you have to pick the right one, otherwise this problem doesn't work. If you would have put R and T equal to each other, that would be wrong. That's why she's telling you to draw the triangle. Because if you would have done that triangle RST, it would have been wrong.
Alright, so now we got to plug it in. So what would the measure of angle R be? So 9 times 5 plus 2. Good. Angle S we know should be the same, but go ahead and plug it in, make sure we did it right. So now we have 13 times 5 minus 18. 47, good. And then angle T, 17 times 5 plus 1. Alright, any questions on number 8?